Welcome to the deep dive. Today we are plugging into something really fundamental. One of the most essential bits of gear out there, maybe. The MXR Micro Amp.
Ah, yes. The little white box.
Exactly. It's so simple, but it really set the standard for boosting your signal without wrecking your tone. We're going to get into the original MX133 and the newer M133.
It really is the ultimate utility player, isn't it?
Yeah.
When people say clean boost, honestly, they're often picturing this circuit or something derived from it. Its whole job is just make things louder.
Right.
But do it cleanly without adding a ton of its own character or distortion or noise. That's the goal.
And for you listening, understanding this little pedal is actually pretty key for getting your whole signal chain sorted out. I mean, think about it. We face this basic physics problem, right? Every cable, every pedal, especially long runs, it just eats away at your signal. Highs disappear, volume drops. It's like death by 1,000 cuts for your tone.
That's a perfect way to put it. Signal degradation. It feels like your tone's getting kind of muffled, losing its edge, its chime. The micro amp is the fix. It just pushes clean voltage back into the line.
Ah, okay.
And it solves that other headache, too, the compatibility thing. You know, you switch guitars maybe from single coils to humbuckers.
Oh, yeah, totally different output levels.
Exactly. Suddenly your amp settings are way off. This pedal is like the quick volume knob to just match things up easily.
So it's essential knowledge if you're serious about optimizing your signal path. And historically, this thing's got, well, serious roots. It's from that classic MXR reference era.
Right. The golden age, you could say, sort of 1970s into the early 80s. That MX133 is right in there.
Okay, so let's start there. The vintage MX133. You see them around, usually that white box, block logo. But what really defined those early ones?
Well, it was functional minimalism,
Right.
really dictated by the tech of the time. The very first MX133s, battery only. That was it.
Just battery.
Yeah. And crucially, no LED indicator light. So you never really knew for sure if it was on.
Wait, seriously? No LED?
None on the earliest ones. And no standard DC power jack either, just the battery clip inside.
Hold on. So, you're on stage, you stomp on it. If the battery dies mid-song, you just wouldn't know until the boost disappears. No light or anything.
That's vintage gear for you. Part of the charm, maybe, but definitely part of the potential frustration. You had to remember to unplug the input jack after playing, otherwise the battery would drain overnight.
Of course.
And you just had to use your ears. Simple function, but maybe complex upkeep for the players back then.
Man, that really makes you appreciate modern pedal boards, doesn't it? Okay, so let's get inside the box, electronically speaking. The circuit. Why is it still so respected? What makes it sound so transparent?
The genius is really how simple it is. Intentionally simple. The whole thing is basically built around one single op-amp stage.
Just one chip doing the work?
Pretty much. But the clever part is how they powered it. They use something called a virtual ground circuit for biasing.
Whoa, okay, virtual ground. That sounds technical. What is that, and why does it matter for biasing? Break that down a bit.
Right, good point. So biasing just means setting up the internal voltages so the chip, the op-amp, works correctly in its happy place. Normally for an op-amp, you'd ideally want both a positive voltage and a negative voltage supply.
Like plus 9V and 9 into 9V or something?
Kind of, yeah. But a 9V battery only gives you positive voltage, right? Plus 9V in ground, you don't get that negative rail.
Okay, so you've only got half the power source you'd ideally want.
Exactly. So the virtual ground circuit is a smart little trick. It creates a reference point electrically halfway between that plus 9V and the actual ground. So at 4.5V.
Oh, okay.
And this lets that single 9V battery effectively power the op-amp as if it had both positive and negative supplies relative to this midpoint. It keeps the circuit simple, saves space, perfect for a tiny battery-powered box.
That is pretty clever engineering. Okay, but for the guitarist, the magic isn't just the power, it's how it interacts with the guitar pickups, right? Let's talk impedance. That seems crucial.
Oh, absolutely. This is like the core engineering principle of the micro amp. You need a really high input impedance. We're talking mega ohms, usually around 1 mega.
And why is that so important? What happens if it's too low?
If the input impedance is too low, it loads your guitar pickups.
Okay, loads them. What does that actually sound like? If you're the player, what do you hear?
It sounds like your tone just died a little. You lose the sparkle, the high-end clarity. Your guitar pickups are these sensitive coils, right? If the very first thing they see electrically is a low impedance, it kind of dampens their natural resonance. The tone gets muddy, sluggish.
So the high impedance lets the pickups breathe, basically.
Exactly. The 1 May input on the micro amp is like, it's barely there, electrically speaking. It tells your guitar, hey, I'm listening, but I'm not going to interfere. You do your thing.
So it listens carefully. Then what?
Then, once it has that pure signal and amplifies it, it needs to send it strongly down the line. So the output impedance is designed to be very low, sub-kilo, typically around 470 ohms.
Low output impedance. Why is that the goal?
Because that low impedance can effectively drive the signal through whatever comes next, long cables, other pedals, the input of your amp, without losing strength or clarity.
Yeah.
It stabilizes the signal chain after the boost.
Got it. So high impedance in for purity, low impedance out for drive. Makes sense. And you mentioned it's clean. Does it use filters to keep it that way?
It does, yeah. There are capacitors in the circuit, but their job isn't really to shape the tone in an obvious way like an EQ. It's more about maintaining integrity.
How so?
They filter out stuff you don't want, like any potential DC voltage that could cause pops, or maybe some extreme low-frequency rumble or super high-frequency hiss that might sneak in. They ensure the boost stays flat across the main guitar frequencies, the 20 hertz to 20 kilohertz audio band. Keeps it transparent.
Okay, now the fun part, using it. The specs say it can deliver up to, 26 dBs of gain? That sounds like a lot of volume boost. If it's clean, how do you use that much gain without it just becoming, painfully loud or distorted?
Well, that's the key where you send it. If you just plugged it into a totally clean, high-headroom solid-state amp and cranked the micro amp, yeah, it would just get incredibly loud and stay clean.
Okay.
But that's usually not how players use it. The magic happens when you use that gain strategically to push the input stage of a tube amplifier.
Ah, okay. So explain the difference then. How is using this boost different from just stepping on, say, a tube screamer or a fuzz pedal? They add dirt too.
Totally different mechanism. A distortion or fuzz pedal creates the distortion inside the pedal's own circuit, clipping diodes, transistors pushed hard, whatever.
Right, the pedal makes the sound.
Exactly. The micro amp, though, it just adds clean gain. The distortion, the overdrive, the crunch that happens externally, it happens inside your amplifier's preamp tubes because you're hitting them so much harder with signal. You're forcing the amp itself past its clean limit.
I see. So you're getting your amp's natural overdrive character, just more of it and sooner. A Marshall still sounds like a cranked Marshall, a Fender, like a cranked Fender.
Precisely. You're making the amp do what it does best when pushed, just more intensely. It adds that beautiful harmonic richness, sustain, compression, but the core tone is still your amp. It's arguably the cleanest way to get natural saturation.
That makes a lot of sense. And that strategic use kind of leads us into the modern era, doesn't it? After the vintage MX133 ran its course, the brand changed hands. Dunlop took over MXR.
That's right. And Dunlop had a pretty smart approach with the reissue, the M133.
Right.
They basically said, okay, the circuit itself is classic. Don't mess with that core sound.
If it ain't broke.
Exactly. But let's fix all those practical headaches from the vintage ones. Make it easier for modern players to actually use on their boards.
Which brings us the things we just expect now. The modern M133 reissue. Finally, it has an LED indicator, if it's on or off.
Thank goodness, right? And, crucially, a standard 9V BC power jack, the little barrel connector everyone uses, so you can run it off a power supply, not just batteries, though it still takes a battery, too.
No more unplugging cables constantly. And what about the bypass? That was sometimes an issue with older pedals.
Yep, they addressed that, too. The reissue uses a hardwire bypass. So when the pedal is switched off, your guitar signal physically goes straight from the input jack to the output jack through wire. True bypass.
Meaning no tone suck when it's off.
Exactly. It preserves your signal integrity when bypassed, which wasn't always guaranteed with older switching methods.
Okay, let's hit the specs on the reissue, because the manual gets really precise, which kind of confirms they stuck to those original design ideas. Still just the one knob, right? Gain.
Just the one gain knob, simple as ever. And it still goes from zero gain, like a buffer, all the way up to that plus 26 dB maximum boost.
And the impedance numbers, did they nail those?
They did. The specs confirm the input impedance is exactly 1 mega ohm. Bang on. That guarantees it won't load down your pickups, preserves that top-end clarity.
Okay, and the output side?
Output impedance is listed at precisely 470 ohms. Again, very low. Perfect for driving the rest of your chain without signal loss. But the spec I find really impressive is the noise floor.
Noise floor. What's the number?
It's rated at 880 dBV. That's measured A-weighted, even at maximum gain.
Minus 80 dBV. That sounds really quiet. What does that actually mean for me as a player plugging this thing in?
It means the pedal itself is incredibly quiet. Think about it. You're potentially adding a huge amount of gain, 26 dBV. If the pedal itself generated any hiss or hum.
Oh, right. You'd be amplifying that noise along with your guitar signal. It'd be super noisy.
Exactly. But NK80 dBV means it adds virtually no noise of its own. So when you turn that gain knob up, you're boosting your clean guitar tone, not a load of background hiss. It really speaks to the quality of the components and the design.
Wow. And it barely sips power too, right?
Oh, unbelievably efficient. The current draw is listed at just 2.5 milliamps.
2.5 mini! That's nothing.
It's tiny. I mean, compare that to a lot of digital pedals today, pulling, 100, 200, even 300 milliamps. This thing can run on a battery for ages or fit onto any pedalboard power supply without even thinking about it.
That's great. And maximum output level before the pedal itself clips.
Rated at +6 dBV. So it gives you plenty of clean headroom before the op amp itself starts distorting. It stays clean over a wide range.
Okay, let's switch gears slightly to the collector side of things. Vintage gear always has weird variations, rare runs, anything particularly interesting with the old microamps.
Well, most of the vintage ones you see are generally dated between about 1979 and 1984. But the real sort of unicorn piece is the late 1983 10th anniversary edition.
Ooh, 10th anniversary. Sounds cool. What was different about those?
They actually broke the mold. They were finished in black paint instead of the usual white.
Black, okay.
And significantly, they were kind of transitional. They were some of the very first vintage units to actually have an LED indicator and a power jack, although it was the old-style 18-inch mini phone jack, not the modern barrel type.
Ah, so they were already starting to add the features people wanted, even before the Dunlop era.
Exactly. They kind of hint at where things were heading, but they're super rare.
Okay, but here's a question then. If those late 83 anniversary ones had the LED and a power jack, why do collectors often prize the really early ones, the battery only, no LED versions even more? Seems like you'd want the more practical one.
It comes down to that idea of like original purity.
Yeah.
The very earliest ones, completely untouched, represent the absolute first, simplest version of that circuit. Just the op amp, the gain knob, the jacks, the battery clip. That's it.
The raw essence of the design.
Kind of, yeah. But you're right, it is counterintuitive from a usability standpoint. The reality back then was different.
What do you mean?
Well, think about it. If you were a gigging musician in the 80s, having no LED and only battery power, or maybe that weird 18 jack, that was a pain.
Right, you'd want to fix that.
Absolutely. So tons of those original microamps that actually got used on the road ended up getting modified. People drilled holes in them to add their own LEDs, maybe swapped the jack for a standard Boss-style one.
Ah, so finding one that wasn't modded is the trick.
Exactly. The fact that an original battery-only unit somehow survived 40-plus years without someone taking a drill to it.
Yeah.
That's what makes it rare and prized by collectors today. It signifies authenticity, that it wasn't subjected to those practical, necessary at the time mods.
That makes total sense. The survivors are the ones that maybe didn't have to endure the rigors of constant gigging and the need for updates.
Precisely. And the amazing thing is how many do survive and still work perfectly, because the design is just so simple and robust. One chip, a few resistors and capacitors, a pot. Not much to go wrong.
Yeah, very few moving parts internally.
It's a testament to really solid utilitarian engineering. Minimal complexity leads to maximum durability. They were built tough.
Okay, so let's try and wrap this up then. Synthesize what we've unpacked here. The MXR Micro Amp, its brilliance wasn't in some super complex new effect. It was about stripping amplification down to the bare essentials. Right?
Absolutely. A simple, clean op-amp circuit, but paired with really smart impedance matching high input, low output. That's the recipe.
And that recipe delivers significant, truly transparent gain, making it this incredibly versatile tool. You can use it for just matching volumes between guitars.
Yep, a little matching.
Compensating for signal loss and a big pedal board.
Fixing that tone suck.
Or, maybe most excitingly, using that clean gain to just slam the front end of your tube amp and get that pure, natural overdrive sound.
Making your amp sing, basically. It's just an indispensable building block.
Okay, so let's leave the listener with something to chew on, a final thought.
All right, so we've established the micro amp is fundamentally simple, right? A single op amp, minimal parts count, but with spot-on impedance matching, providing transparency and robustness.
Yeah, simple but effective.
So here's the question for you to think about. When you look at the boost pedal market today, you see tons of boutique options, often with, complex circuits, maybe multiple gain stages, fancy rare components, big price tags.
Right, the $300 boost pedal.
Exactly. How much of the perfect tone that people are chasing with those complex, expensive pedals is actually down to the circuit complexity itself? Versus just getting back to these fundamental principles. Minimal components chosen deliberately for transparency, combined with that crucial perfect impedance matching like the Micro Amp did decades ago. Is more complexity always better, or is the elegant simplicity of something like the Micro Amp still the most effective path to just clean, powerful boost?
Yeah.
Something to mull over next time you're thinking about boost pedals.